All right, so I'm recording on Viddle now. So for people watching this in the future, you're not seeing my Zoom face because I'm recording it on Viddle for better quality, but that's okay. You're not missing much. And the chat never shows up on the Viddle on the Zoom recording anyway, so we're good. So I'm recording. Excellent. I have the chat box open. We got 20 people here. I'm so surprised that 20 of you showed up. I'm happy. I am thrilled 20 of you showed up. Maybe that's what I get for getting calculus students. Calculus students are always really ready and in it to win it. All right, so today we're going to talk pre-calculus. So first week, we're keeping it light. All the stuff I'm going to talk about today is stuff that you should have learned at some point in time prior to now. I want to talk about these things because, to be honest, most of what I'm about to talk about is literally just algebra. And the algebra is so important that we can't not talk about it. It's going to be a little bit scattered. I don't have a very defined plan of the things I'm going to talk about, but there's a lot of things that I want to mention. So we'll go ahead and get started. Let's see. Is this the right pen? Yes, that's the right one. Is everybody able to hear me okay? Is everybody able to see the screen okay? Excellent, excellent. And is everybody having a fantastic, whatever it is, Wednesday today? Who doesn't love Wednesdays, right? Yeah? All right. Well, let's get to it. So this is the first time I'm doing a live lecture on the iPad with the Viddle. So I'm really excited. We're just going to see how it goes. Trial and error. Alrighty, tidy. So let's talk about the thing that matters most. So I'll tell you a short anecdote about what matters most. I was at a meeting, math department meeting, and what we were doing was we took every single class and we wrote it on the board. So, it was like Math 95, Math 96, blah, 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 all the way up through our highest math course, which is not math. It's not Math 181. There's much higher courses than that, but that's fine. Let's just pretend this was the way it looked. And it was like the skills we wanted when they came in and the skills we wanted them to have when they went out. And we did this for every course. On the out part of Math 96 was factoring. And we started up here and we worked our way down here, and every math class in this area right here had factoring. There was factoring written under every single class, from our highest math class downward. So factoring is incredibly important. We need to talk about it because it is the thing that students tend to forget, but it is incredibly important and it doesn't stop being important. Was there a more efficient way of doing this? Probably, but I'm going to do it this way. All right. So what doesn't tend to be a problem are the factoring problems that are like x squared minus 3x plus 4. So these ones, hopefully this one is something that you've seen that looks relatively familiar. This would factor into x minus 4 times, oops, I meant to make this a minus sign here. Ha ha ha. Times x plus 1. The factoring when you have your leading coefficient as 1 tends to be okay. If that's not okay, you're going to need to do a little bit more reviewing, but the ones that I'm more concerned about are these guys here. When that leading coefficient is no longer 1. I have a particular way I like to teach the factoring on these. You probably, if you remember how to factor, you might have your own way that's different than my way, and that's totally fine. You can use whatever factoring method you want. For those of you who are needing a refresher on factoring, I'm going to teach you my bottoms-up method, which works. And it's a little bit weird, and some teachers don't like it because it's a little bit weird. But the bottoms-up method works, and it's my favorite method, so I'm going to teach it. I'm going to erase this. Look at this cool stuff I can do because I'm no longer on big blue button. Bam. How cool is that? So cool. All right, so with the bottoms-up method, the first thing you're going to do is you're going to multiply A and C together. So remember, if you have a quadratic, A is this first number, C is this last number. You're going to multiply these two together, and then you replace C with whatever that multiplication is. So if I go here, I'm taking this 4, I'm multiplying it with this 8, that's an arrow. 4 times, we'll say -8 because it's a -8 there. -32. So I'm going to replace this -8 with a -32. Oops. And then I'm going to get rid of the A. And if you have any questions, feel free to put those in the chat box. So what you're left with is t squared minus 31t minus 32. You can now factor this like you would normally factor any quadratic. You're not done at this point, but you can factor this. So this one would factor into t minus 32 times t plus 1. Questions up through this point? My dog is outside growling at stuff. So I'm going to move that up a little bit. Here's where it gets a little weird. You're going to divide both of these constants by the number that you disappeared. So like I like to say, like you disappeared the A. You're going to divide by the disappeared number, right? Because the 4 disappeared here on both of these constants, and then you reduce the fraction. If possible, because you can't always reduce it. So we disappeared the number 4. This was the disappeared number. So I'm dividing by 4 here. (32) divided by 4, that reduces down to 8. And then we have t plus 1/4. You are not done. Clearly, if you were to multiply this thing out, you would not get 4t squared minus 31t minus 8, right? You would not get that if you were to multiply it out. Like, you just look at these, the t's would multiply together and you'd get t squared, which is not this. So this brings us to our last step, which is bringing the bottom up. And I think what I can do is just shrink this a little bit. So I don't think I can scroll. Oh, I can scroll. Ooh, I can scroll. Just a little bit, but that's enough. You bring the bottoms up. I promise this looks a lot more hassly than it actually is. So if there are any denominators left over, which there are right here, you bring it back up to the front right here. So you end up with t minus 8 and then 4t plus 1. And this is the final factoring. It looks like a lot because I wrote out all the steps. A lot of this can start being done in your head. Once you can do it in your head, it goes really, really fast. But we can double check this. If you were to FOIL this out, you'd get 4t squared plus t minus 32t minus 8, which would simplify to 4t squared minus 31t minus 8, which is what we started with right up there. So I'm going to do a few more examples, but does anyone have questions so far? You probably want to wait till you see a few examples before asking questions, but if you do have one, I'm ready to answer it. Okay, so let's do some examples. And I'm going to do one. I'm going to give you guys one to try, and then we'll move forward to some other stuff. So let's go ahead and do 4x squared plus 4x minus 3. So using my method, I'm going to take the a, I'm multiplying it with the c, and then it gets disappeared. So 4 times negative 3 is negative 12. So this 4 will disappear, and this will turn into a minus 12. So we have x squared plus 4x minus 12. This factors into x plus 6 times x minus 2. The number that we had originally disappeared was the 4. So this 4 kind of comes, almost like it comes down as a denominator here. Both of those fractions can be reduced. So 6 over 4 is the same thing as 3 over 2. And 2 over 4 is 1/2. So I've reduced those fractions all the way. This part's very important. If you do not reduce the fractions, nothing will come out right. So like imagine if I, on this step here, brought the bottoms up immediately, I'd have 4x plus 6 and 4x minus 2. If you multiply these first two terms together, you'd get 16x squared, which is not 4x squared. So it's really important that you reduce the fractions and then bring the bottoms up. So I get 2x plus 3 and 2x minus 1. If we multiply that out, if we FOIL it, 4x squared minus 2x plus 6x minus 3, that's going to simplify to 4x squared plus 4x minus 3, which is what we started with. Questions on that one? Here, let me grab my Oh, textbook here. So that's just one way of doing it. There are multiple ways to factor. That's the way that I have found is nice. A lot of people are able to do it in their head. I am not a person who likes to do these in my head. I don't know why. I never have. I never will. I would rather just write it down. A lot of people are, not a lot. Some people are good at guess and check. I'm just not one of those people. So I like to have a method that always works and doesn't require me sitting here and guessing numbers for a while. So let me give 2 of them. I'm going to have you guys work on them and then go ahead and when you have an answer, put it into the chat box. And once again, you can use whatever method you want, but the method I show you is one of the methods that you can use. Go ahead and give those a shot real quick. And feel free to, as soon as you have an answer, put it in. All right, so we're getting some answers for the first one. Keep working, keep working. Excellent. It looks like we're getting a few answers in here. So for that first one, I'm just going to kind of quickly write down the work that I would do for it. If you have a different method, once again, I'm all for your creative freedom in mathematics. So I see a few people got 2a plus 3 times a plus 2 on that first one, which is the correct answer. Notice how when I'm doing this here, I kind of skip a step from here to here where I don't reduce this one on paper. That's one way to make this process really fast. Look, you make it from, I won't go back any slides, but you take it from being a very written out process to, 1, 2, answer. And for reference, If you had a plus 2 times 2a plus 3, this is also the same exact answer and a correct answer. Did you get it, Selena? Did you get this one here? Yep, that's totally correct. Absolutely correct. It's whichever one your brain thought of first. Like, your brain either is going to say it's 3 times 4 is 12 or 4 times 3 is 12. So that just changes this step here, but it's same answer and you are good to go. You are good to go. Yes, no panicking. Yeah, so these can be backwards and it's totally fine. For this next one, if I write it out quickly, y minus 3 times 5y plus 1, which looks like what everyone else got, which again is the same thing as 5y plus 1 times y minus 3. Both of those answers are correct. Excellent. So if this is a skill that feels a little foreign, definitely spend some time practicing factoring. I can put up some factoring resources if I make myself a note on paper. But you want to make sure that you know how to factor. Can I answer any questions about factoring? There's a little bit more in factoring I want to cover, but any questions so far? Excellent, excellent. So let's talk about, how do I want to do this? Let's talk about factoring by grouping real quick, and then I'm going to talk about equations. All right, so when you see 4 terms written out and you're asked to factor, I'm not writing the instruction, which is to factor. The instruction is to factor. When you see 4 terms and you're asked to factor, your brain should immediately go to one place, and it is the magical factor by grouping. Ooh, fancy. Beautiful. So when there's 4 terms, you're going to be thinking factoring by grouping. For factoring by grouping, sometimes you have to rearrange things, but for your first go around, you're looking at these 4 terms and you're going to group them into 2 groups, and you're going to pull out the LCD, the common factor. There it is. The greatest common factor. You're going to pull out the greatest common factor from both of these groups. So for this first group, we have 8uv and 6u. They have a 2 in common because 2 can come out of both 8uv and 6u. And then they also have a u in common. And then for that second group, you can pull out a 3. That's their greatest common factor. So if I pull 2u out of that first group, I'm left with 4v minus 3. And if I pull out a 3 from this second group, I have 4v minus 3. Notice that both of these terms have a 4v minus 3 in common. So I want you to kind of think about it as if this were 2u and then a square, right? It doesn't matter what the square is, plus 3 square. We would agree that we should be able to factor a square out from both of these, right? We could factor a square out and be left with 2u plus 3. We can do that same thing with an entire factor. So instead of a square, it's an entire factor. So we factor the 4v minus 3 out, and we're left with, from the first term, if you factor this out, you're left with a 2u. From the second term, if you factor this out, you're left with a 3. So your final answer, 4v minus 3 times 2u plus 3. There are times when you go to factor by grouping where it won't work right away. So I'm trying to see if there's a way I could have had these arranged where it wouldn't work. Yeah. So if instead these had been arranged 8uv minus 9 plus 12v minus 6u, this is the same equation or expression, but arranged differently. I wouldn't be able to pull anything out from the first group, right? From the second group, I could pull out a 6, but that wouldn't work. I couldn't factor by grouping there. So if they had been arranged in this way, you would have to start rearranging them to find ways that worked. So for this one, you might say, well, I know that these guys have u's in common, so I could try putting them together. Or you could say these guys have v's in common, I might want to put them together. But you would just rearrange, because typically if there are 4 terms, it's almost certain you can factor by grouping. Not if you just throw out 4 random terms, but if you see them in a problem. If you see them in a problem, it's probably factor by grouping. Go back here. Questions on this? I promise I'm not drinking alcohol. I'm drinking Monster because I need caffeine right now. I feel like I don't need to say that in the classroom, but I'll say it here. Group 9 and 6. And the 8 and the 12. Let's see. Yeah, so I think you could. So if we did 8uv plus 12v minus 6u minus 9, let's see if it works. So you could take out a 4v from this one, and you'd be left with 2u plus 3 over, undo. From the second group, you could factor out a negative 3. And when you factor out the negative 3, you're factoring the negative out from both of them. So it will become a plus in here. So this would become 2u plus 3. And then you get 2u plus 3 times 4v minus 3. So you get the same thing. So yep, you could totally have done it with the v's grouped together. No problem, no problem. Excellent question. Okay. So let's talk about equations. And we will have another factoring by grouping one, but we're going to talk about it in the equation format. So I'm going to step away from factoring by grouping for one problem and we'll go back to it. Oh, let's see. Question. Wouldn't the v up above still have a, is that a squared? I think that's what a squared since you factored a 6. Wait, or a 2? A 2. Oh, okay. Wouldn't the v up above on, let's see. Oh, right here. Yes. Good call. Right here. There should be a 2. I think I was so focused on the fact that it wasn't going to work out that I, yeah, very good call. I just completely disregarded. There you are. Excellent catch. It still won't factor, but it's good to have that math actually correct there. Other questions on this one? If I see another question come in, I'll come back for it. So equations. Let me kind of start with something straightforward. Yeah, no problem, no problem. So if I have 4x plus 1 times x minus 2 equal to 0. How do we solve an equation like this? Important properties. So you learn about this back in Math 96. There's an important property called the zero product property. And without going into a terrible amount of detail, the zero product property says that if you get 0, so if you multiply two things together and you get 0, that either this one is 0, this one is 0, or they are both 0, right? So if you multiply two things together and get 0, one of the two things has to be 0 or they're both 0. Essentially, you end up with something like this, or something like this. So I think Curable has it there. If we're multiplying these two things together and they become 0, it means one or both of them is 0, and we have to find both answers. So you take each of these factors individually and set the factors individually equal to 0. So 4x plus 1 equals 0, 4x equals -1, x equals -1/4. That's one of our answers. Here, x minus 2 equals 0. So we have x equals 2. So our two answers for this problem are -1/4 and 2. That's a comma. What's really important here is that this side was 0. The zero product property is special because of 0. If you're looking at a different number, I know some of you might still be writing, so maybe I'll just kind of scribble on here. If you have two things that multiply together and give you, I don't know, what's a fun number? 1. It is not true that one of these would have to be 1, right? I can multiply, let's say, 2 times 1/2, and that'll get me 1. And neither of those numbers are 1. 0 is the only number that can be on this side, and we know one of these two things has to be 0. It's special and specific to 0. So if I had, let's say, x minus 1 times x plus 2 equal to 18. If I were giving this on a test in the appropriate class, when I'm making my grading key, if I had given this problem on a test, which if this were Math 96, I would give it on a test 100% of the time, I would have a whole point section laid out ahead of time without looking at a single test of what would happen if a student set each of these equal to 18. Because the mistake is so common that I would already know it was going to happen with at least 25 to 50% of people, and I would have my point structure laid out for it. It's really easy to want to say, oh, well, you set each of these equal to 18, but like I showed over here, that doesn't work. If you have two numbers that multiply together to get 18, 18 doesn't have to be one of them. One of them could be 3 and 6. There's infinitely many combos you can put together that would give you 18. So instead, with a problem like this, you have to multiply out this side, make this side 0 by moving the 18 over, and then refactor it. So one side has to be 0 in order for us to use that zero product property. So if I FOIL this out, right, x squared plus x minus 2 equal to 18. Subtracting 18 on both sides, x squared plus x minus 20 equals 0. Now that this side is 0, we are good to go ahead and set factor and set each factor equal to 0. So this would factor into x plus 5 times x minus 4. This gives you x equals negative 5 and x equals 4. And you could try those numbers out. I mean, you always should when you're solving equations, try the numbers out, right? So if you plug in negative 5, negative 5 minus 1 times negative 5 plus 2 equals 18, question mark. So negative 6 times negative 3 equals 18. Yes, that's true. With 4, 4 minus 1 times 4 plus 2 equals 18. So we have 3 times 6 equals 18. Yes, that's true. So let me, hold on. I'm looking for one I want to have you guys try. I guess we could try this one. Are there any questions so far? Maybe I'll put it over here. So using the same idea, it's a slightly different looking problem. But the idea is similar. Try this guy out, right? 3 times the quantity y squared plus 4 equals 20y. Figure out what y should be. So go ahead and solve that equation. And if you get an answer, go ahead and put it in the chat box. That way I know people are done. So I'm seeing one answer. I want to make sure I give enough time. It's hard to gauge online. It's a lot easier in person to see when people are done. So we got a few different answers. So let's go ahead and try it out. So once again, we have to make one side 0. So I need to distribute and then move the 20y over. So I'm distributing the 3 So I have 3y squared plus 12 equals 20y. I am taking the 20y and moving it to the other side. So 3y squared minus 20y plus 12 equals 0. If I use my bottoms up method, which I'll go ahead and do on the side, I would have y squared minus 20y plus 36. So then I'm thinking of numbers that multiply to 36 and add to negative 20. So I'm looking at two negative numbers. So if you're thinking about negative numbers, because it has to be two negatives, right? Because it multiplies to a positive and adds to a negative. So we're looking at, let's see. It can't be negative 6 and 6. It can't be negative 3 and negative 12. It can't be, it's a big one, huh? So negative 18 and negative 2. In my head, I'm just going through all the multiples. I go through the same process of elimination that you guys are going through in your head. So this y minus 18, y minus 2. Right? We disappeared a 3. There was a 3 here in the beginning. So we're dividing these guys by 3. So we get y minus 6 and then 3y minus 2. So we have y minus 6, 3y minus 2 equal to 0. Setting each of these equal to 0, y minus 6 equal to 0, you get y equals 6. And then 3y minus 2 equal to 0. So 3y equals 2. Y equals 2/3. So I'm getting 6 2/3. 6 2/3. Can I answer any questions on that one? Oh, like if you were checking, so the question, so for people watching in the future, the question is, how would we square 2/3 again? So are you talking about if you were checking it in your answer here? So personally, I don't like dealing with fractions by hand, so I would take my handy dandy calculator and use my calculator to deal with the fractions. But if we were dealing with it by hand, you would be doing, so 3, and then it's 2/3 squared plus 4. I'll just do the left-hand side. So you square the top and you square the bottom. So this would be 4/9 plus 4. And then 4/9. 4 is the same as 36/9, so making a common denominator. So this would be 3 times 40/9. So you have 120 over 9, although the easier way would be to simplify right here. And you'd get 40/3 on this side. And then on the other side, you'd have 20y, so you'd have 20 times 2/3. So you'd get 40/3 on that side too. But the short answer being that you would square the top and the bottom and then have to do a little bit of obnoxious fraction math, unfortunately. Why did you take the 3 from the y squared and give it to 12? Are you talking about
like when you wrote it in green, when you changed it to y squared minus 20y?
Mm-hmm. So when I wrote y squared minus 20y, so I went from this step to this step. Okay, so that's my bottoms up method. So the bottoms up method does 3 times 12. So you multiply these guys together. and then you replace the last number with this. It's just the method that I use for factoring. Different people use different methods. If you're using like the AC method, yours probably wouldn't look like this, but that's from the bottoms up method. Does that make sense? Excellent, excellent. Awesome. Excellent. So then other questions? I'm going to give one more equation. This one I'm going to give to you. It involves factoring by grouping. Let's go ahead and work this one out. Getting some answers. Awesome. Yeah, put your answers in that chat box when you're ready for it. Excellent. All right, we're getting a lot of sames. So I'm just going to kind of quickly work through it up here. If you're still working, then just shield your eyes from the screen while you're working. So it looks like I am getting an answer that agrees with you guys. The important thing, so if you have p squared minus 16, this is a difference of squares. So that splits up into p plus 4 times p minus 4. And I don't care if your answers are out of numerical order down here. That is totally fine with me. All right. Any questions on that one, on the factoring by grouping? there's a little bit more algebra stuff that I want to go through, but I kind of want to talk about some algebra that's not true. So I kind of want to talk about some algebra mistakes that we want to talk about right away. And if you've had me in a class before, you've almost certainly heard me talk about some of these, at least the first one I'm about to bring up. So let's talk about algebra mistakes. I'll put a sad face there. Common algebra mistakes. The first one. A plus b quantity squared equals a squared plus b squared. This is a mistake. I wonder what this guy's like. These are not equal. This mistake is so common and so ingrained in math that it has its own name. It has its own Wikipedia page. You can look it up right now. This is called the freshman's dream. Probably freshman's dream. All right, it has its own Wikipedia page because this mistake is made so frequently. All right, so if you are squaring a sum of two things, you need to FOIL that out. So a plus b quantity squared is the same as a plus b times a plus b. And if you FOIL that, you have a squared plus ab plus ba plus b squared. These guys right here are the same term, like they're common terms, they're like terms. So you get a squared plus 2ab plus b squared. I think where the confusion comes in from this one is what is true is that if you have AB quantity squared, the square does get distributed. So this is equal to A squared, B squared. But this pesky little plus sign right there ruins everything for us. The freshman's dream has many offshoots, many versions. For instance, the square root of A squared plus B squared is not, let me use my red pen here, is not A plus B. So it's really tempting to want to do this. It's really tempting to want to distribute that square and say, well, the square root of A squared plus the square root of B squared is A plus B. But that doesn't work. So you can't distribute the square root over a plus sign. If there's a plus sign in here, you can't distribute it. This actually doesn't reduce to anything at all. There's nothing you can do about this. However, what is true is that if you have the square root of A squared times B squared, that you can distribute the square root. And if you're assuming that A and B are both greater than 0, we'll just make that assumption. This would be A times B. So things that are true when there's multiplication might not be true when there's addition. So common one, freshman's dream. If you do it on an exam or homework, I'm gonna put a sad face next to it, right? Because because it is. I will make a whole song and dance about the freshman's dream. It doesn't work. It doesn't happen. Go read the Wikipedia page. It exists. That is all. Right. 2, let's talk about division involving 0. All right. So there's 3 different ways we can kind of involve 0. So you can have 0 divided by a number that's not 0, a number divided by 0, and 0 divided by 0. Only one of these cases, so there's 1, 2, 3 cases here. Only one of these equals 0. Of 1, 2, and 3, which of these actually equals 0? Getting some guesses in. Got some 1s, a 3, another 3. So I'll go ahead and say it is 1. 1 is the only one that actually equals 0. This guy over here, this is undefined. And this one is indeterminate. We are going to be talking about this in calculus. This is actually what we're going to be doing in this class really soon. What we're going to find out is that when we use limits, the concept we'll be talking about really soon, these end up being either positive or negative infinity. And a situation like this, when we use limits, could be like any number. So it's indeterminate because there's any case, like you can make different arguments about what 0 over 0 should be. So what you could say is that for 0 over 0, you could say, well, any number over itself, any number divided by itself is 1. Right? This is true. Like 2 divided by 2, that's 1. 3 divided by 3, that's 1. Negative 7.28 divided by negative 7.28, that's 1. Any number divided by itself is 1. So that's one argument you can make, right? But you could also make the argument that 0 divided by any number is 0, right? 0 divided by 1 is 0. 0 divided by 3 is 0. 0 divided by negative 7.28 is 0. So there's 2 arguments here that I can make that one of these arguments says that the answer should be 1. One of these arguments says the answer should be 0. There's actually a bunch of arguments that can be made, and this turns out, depending on the situation you're looking at it could be any number of things. So that's the indeterminate situation. However, if on your calculator right now, you do, so for the number divided by 0 case, let's put a 1 on top of a small number, so like 1 divided by 0.0001, right? You put this in your calculator, you're going to get 10,000. You put in even more zeros, 1, 2, 3, 4, 5, 6. You put in 6 zeros, you're going to get a bigger number. And the smaller that you make this number, the bigger this number is going to get. And it's the same if you put a negative under here. If you put a negative sign down here, this number is just going to become negative but large. So the closer that you get to 0, the closer this number becomes to 0, the bigger this number over here gets. So it's a much different thing than what happens up here. This is something Yeah, so that's exactly 100% it, Catherine. Catherine said, every number closer to 0 approaches infinity. Yeah, so the smaller that number gets, the smaller your denominator gets, the bigger your answer is getting. And this number, if you can go as close to 0 as possible, this number is going to go as close to infinity as possible. So it's what we're going to be talking about very soon, but it's a really important idea in calculus. So the only situation where you actually end up getting 0 is if you have 0 divided by a non-zero number. So if you have 0 divided by 7, that's 0. 0 divided by 8, that's 0, and so on. Questions on that idea with zeros, dividing by zeros? Number 3, negative exponents. We're going to be dealing a lot with negative exponents in this class. You're going to see them frequently. So in general, negative exponents put something down in the denominator. So for instance, if you have a to the negative 5, this is 1 over a to the 5. I like to think of negative exponents as the variable being unhappy with where it is in life and it needs to move. So if you have 1 over b to the negative 6, that means that b is unhappy in the denominator, and so he moves up to the numerator and becomes positive. So in general, negative exponents move a term to the denominator if they begin in the numerator. But maybe what I'll say, how do I want to say that? I'll just say this. Okay, to the denominator if they begin in the numerator. Negative exponents in the denominator move the term to the numerator. So we're really not going to be dealing with this particular case a lot. We're going to be dealing a lot more with this particular case. And there's some strange things that kind of happen. So in general, if I said, let's say a squared b negative 5, and I asked you to write this without negative exponents, I would normally tell you, all right, well, the b has a negative exponent, so he's unhappy, so he's going to move to the denominator, but the a has a positive exponent, so he's going to stay up top. And this is how you'd write it, and this is correct. And this doesn't tend to be an issue. However, if instead of an a, I write a number, this is where students get a little bit confused. So if I said 2b to the negative 5, it may be tempting. Let me put a red X in here. It may be tempting to say this is 1 over 2b to the 5th. But this is not correct. This is incorrect. The 2 itself does not have an exponent on it. So just like the a squared got to stay in the numerator because the negative 5 only belongs to the b, in this case down here, the 2 doesn't have the negative 5. The b is the only thing that has the negative 5. So how this really should look is 2 stays up top and then b to the fifth goes to the bottom. So then the question comes, well, how do you know if the -5 is attached to just the b? The only way that the 2 gets the -5 is if there are parentheses. So if I said 2b to the -5, like this would be 1 over 2b to the 5. We know that the 2 belongs in the denominator along with the b if it's part of a group that has a negative exponent. If you have 1/2 times, let's use a new letter, u to the -7. 1/2 times u to the -7. The 2 right here is already in the denominator. So you could write this, let's say, as 1/2 times u to the -7, right? That's just me adding a multiplication symbol in where the multiplication was already assumed. And u to the -7 would be 1 over u to the 7. With fractions, you multiply straight across, so you get 1 over 2u to the 7. So this guy right here is the same as 1 over 2u to the 7. The same type of approach is used when working backwards, and that's the way that we're going to see it most frequently. We're most frequently in calculus going to be using the backwards direction of this. So if I ask you to write in exponential form, (1 over 5y cubed). The common mistake would be to write this as 5y to the -3. This would be wrong. Right? For many reasons. But if we just look back a page one more time, right, we see that 1/2 u to the -7 became 1 over 2 u to the 7. So if we move in the backwards direction here, notice that the 2 doesn't come up with the u because the 2 doesn't have an exponent attached to it. The only thing that has an exponent attached to it is the u. So this 5 doesn't have a 3 attached to it. This 5 is in the denominator regardless. It's only the y that has the negative exponent. Does that make sense so far? Can I answer any questions right now? Because I know this is a bit confusing, but this part is really, really important. We're oftentimes moving the forward direction is a little bit nicer than moving in this direction, and this is the direction we're going to use most frequently. Okay, so I don't see anything in the chat box. If we have, let's say 10 over x to the 4th. When we go to write this in exponential form, the 10 stays in the numerator and the x gets the negative exponent. So you might say, well, how is that in the numerator? It's because there's a secret 1 down below that we'd never write. But the 10 would stay right with it. All right, the 10 isn't moving. The one that gets really confusing is honestly this one here. So why don't you try? I'm going to add a little bit of fun on here. Go ahead and rewrite this one in exponential form. And by exponential form right now, really what I just mean to write it with a negative exponent, if that makes more sense to you. Write it with a negative exponent. And you don't have to put it in the chat box if you don't want. Just you can write it on the paper, but write it in its negative exponent form. Make it a little more clear here. So what you should be getting is something like this. Yep, exactly. And if you even wanted, you could write this as 2u to the negative 12 over 7. Does this all make sense? How these go? How these work? Excellent. Okay. Along with exponents, not necessarily the negative exponents, but just exponents in general, mistakes come about when we kind of question what the exponent belongs to, which we kind of talked about in these ones here. This is number 4. I think this is 4. Just exponents in general. So one of the fun ones, and if you have a calculator near you, you can do this. If you put these into your calculator, you're going to get different answers. Okay, you're going to get different answers. And you might think that your calculator is broken or this is some weird math trick, but it's really the calculator doing exactly what it's supposed to do. So if you put this first one in the calculator, you're going to get -9, and if you put the second one in your calculator, you'll get +9. I could show you. You should just try it yourself. The reason being, this 2 is not attached to the negative sign. So the way that your calculator correctly reads this is -3 squared. So it's doing the 3 squared part first, and it gets -9. Okay, so if there are no parentheses, the exponent only assumes that it's on the thing directly next to it. I'm sorry, my handwriting is kind of chicken scratch. Summer does that to me. Yeah, so Tyler says, I always imagine the negative being like an imaginary -1, and it's exactly like that. So it's exactly as if you had -1 times 3 squared. That's exactly what's happening. It's a good way of thinking about it. So you get -1 times 9, and you end up with -9 there. So where I see this mistake kind of playing out, and doesn't look like I have the blue selected, but do I? Oh, I do. Just kidding. This happens even in calculus. Is just in math, there's a lot of things to remember, right? So some of the things that you learned a long time ago start to kind of trickle out, and that's just normal. I'll see things like 2x squared incorrectly becoming 4x squared, right? This 2 does not belong, the square does not belong on the 2. 2x squared is just 2x squared. Where I also see mistakes is if you have 2x quantity squared, this is not 2x squared, right? The square gets distributed. So you have 2 squared times x squared, which is 4x squared. So making sure that you distribute the square is really important. Questions on any of these things? I had a list of ones that I was going to talk about. Let me just double check and see if there was any ones on here. Okay. Let's talk about square roots. So somewhere in your memory might be the statement, when you take a square root, you have to always put a plus or minus. Oh yeah, I can totally go back for a second. Absolutely. No problem. And as a note to everyone else, if I'm going too fast, if I move from a slide too quickly, please just let me know. I'm happy to go back a slide. It's hard to kind of gauge how everyone is writing and how fast we're going because I'm here and I can't see everybody writing. No problem. So square roots, you might have somewhere in your memory that when you take a square root of something that you should always put a plus or minus. And that's true, but also not true. Yay, math, right? So if I take the square root of 16, this is positive 4. It just is. This is positive 4. It is not plus or minus 4. It is positive 4. When we take the square root of a number, we always assume the positive root. It's called the principal root, the principal square root. So when we take a square root of a number, we always assume of a number. That's important. We always assume that the output is positive. Your calculator does this. Your calculator doesn't say plus or minus 4. Your calculator will say positive 4. However, if You are taking the square root of a variable that is squared. All right, if you are taking the square root of a variable that is squared, the answer is plus or minus x. All right, so let me do this in a way that'll maybe make more sense here. So if I say x squared is equal to 16, and I'm trying to solve this. You can solve this by moving the 16 to the other side and then doing a difference of squares, but you can also do this by using the square root property. So I can take the square root on both sides, but when I do that, I have to put a plus or minus on the other side, and I will explain why. So the square root of x squared is x. The square root of 16 is 4, so you get x equals plus or minus 4. Reason. So my original statement here was that the square root of x squared equals plus or minus x. The reason is if you go to even just this step here where I say the square root of x squared is equal to 16, is equal to the square root of 16. I can plug in, so this side is always 4, right? I told you the square root of a number, always positive. So this side is 4. But if I'm plugging in options here, if I plug in positive 4, then I get the square root of 16 equals 4, and that's a true statement. So this is when I plug in x equals positive 4. If I plug in x equals negative 4, I get the square root of negative 4 squared is equal to 4. If you square negative 4, you get 16, and then you get 4 equals 4. It's a true statement. So both 4 and negative 4 make this statement true. So I put the plus or minus over here on this guy so that, because it doesn't matter. So either you're putting the plus or minus on the x or you're putting the plus or minus on the 16. That plus or minus doesn't matter which side it ends up on, but it's easier in the case of using the square root property to just put it on the number. So the important thing, and I know it's confusing, but the important thing is the square root of a number always going to be positive, but the square root when you're doing variables needs to have a plus or minus. And the variable part there is important. Let's see, how much time do we have? We have until 1:50, right? I think that's what it says. Yeah, 1:50, cool. 25 minutes, excellent. Can I answer any questions on this part? Normally this isn't a problem. Honestly, I think it's more confusing when you think about both these things at the same time. There's a very good chance that if I separately talk to you about this concept and this concept that you would not mix them up. But I do like to talk about them together just to bring out that discrepancy, that there is a difference between taking the square root of a number and taking the square root of a variable. Right. Okay. So back to a little bit more algebra. Let's talk about complex fractions a little bit, because complex fractions are something we're going to be dealing with very, very, very soon. So combined into one single fraction, 1 minus 9 over y squared, 1 minus 1 over y minus 6 over y squared. All right, so this is known as a complex fraction. A complex fraction is fractions within fractions. So we have like one big fraction here, and then we have several smaller fractions that are within our big fraction. When I say combine into one single fraction, I mean one single non-complex fraction. So one single fraction where there's just one thing in the numerator and one thing in the denominator. There's no fractions within fractions. So essentially get rid of the fractions within the fractions. There are multiple ways of doing this. The way that might come to your head immediately is combine the denominator into one fraction and combine the numerator into one fraction so that you get something like baby fraction on top divided by baby fraction on the bottom. And then you can do the thing where you multiply by the reciprocal of the denominator, which works totally fine. It does take a lot longer than another way of doing this. So my it's not a cheating method, but my quick method for doing this. You want to find the least common denominator. So you look at all the denominators. Oh no, I just got rid of my blue. So one of the bad things about Viddle is you may have noticed that I always touch this guy right here. And if you're watching this in the future, you won't be able to see what I'm doing because it's only recording my screen. But if you touch this guy right here, you can choose a color, right? And I always use this color. I always use this one to do that because if you tap away from the color that's custom chosen, it doesn't come back. So if I make a custom color right here, and I wanted to use that, and then I went back to black, there's no way for me to get back to that custom color. Sad. Anyway, neither here nor there. You want to find the least common denominator. So you're looking at all the denominators within your complex fraction. So the fractions within fractions, you're looking at their denominators, and you're looking for the least common denominator. In this case, that's going to be y squared. So it's the smallest thing that all the denominators can multiply to. So y squared is already y squared, so it can multiply to y squared because it already is. And then if you multiply y by y squared, y by y, you'll get a y squared. So you take the least common denominator, which is in this case y squared, and you're going to multiply the numerator and denominator of the big fraction by the LCD. So I'm coming here and I'm multiplying the numerator and denominator of the big fraction by the LCD. The first time that I do this, I'm going to write out every step, but there are shortcuts you can take in your head to make this process a lot faster. So distributing these really go in the numerator, so maybe I shouldn't write it like that. Distributing the y squareds, you get y squared minus 9y squared over y squared. On the bottom, you get y squared minus y squared over y minus 6y squared over y squared. So what I've done here, just to kind of recap, I took and I found the LCD, which is y squared, and then I multiplied the top of the big fraction and the bottom of the big fraction by y squared. This is going to end up clearing out our denominators, and I distributed the y squared to every single term. So this y squared here came from distributing. This y squared down here came from distributing. This y squared here came from distributing. And we can simplify from here, right? So these y squareds cancel out. These y squareds cancel out. For this y squared, if you have y squared over y, this is just the same thing as y. So you have y squared minus 9 over y squared minus y minus 6. The top can simplify to y plus 3 times y minus 3. On the bottom, y minus 3 times y plus 2. We can cancel these y minus 3's out, and if we were being really careful with our work, if we canceled those, we would say y cannot be equal to 3. We're saying this because if y were equal to 3, it would cause problems because you would be dividing by 0. And we get y plus 3 over y plus 2, where y is not equal to 3. So that's simplifying a complex fraction. This is something, as we get into the limit section, which is literally what we're going to start talking about on Monday of next week, we're going to be doing a lot of complex fraction stuff. A little bit at least. There's going to be enough complex fractions that you're going to want to know how to deal with complex fractions. Can I answer questions about this? I'm looking to see if I could find one for you guys to do. I know it's a little complicated, especially if you haven't thought about this particular skill in a while, but it is very important. Nope, I did mean, so there was a question asked, do you mean where y is not equal to 2? And the answer is no. So in this statement right here, you can assume that y is not equal to negative 2 because you can see the y plus 2 in the denominator. However, what's not explicit is that you can't plug in 3. So if you looked at this, you would think there's no reason I can't plug in 3, right? I would look at this and say, 3 is fine in here. You'd look at negative 2 and say, okay, negative 2 is not fine. And if you wanted to be really specific, you could put negative 2 in here as well. But the big problem is that we secretly eliminated 3, y minus 3 up here. So that was what we secretly eliminated. And this answer down here doesn't reflect that 3 is an issue. But if we went back to the very original and we tried y equals 3 in the very original, we'd have 1 minus 9 over 3 squared all over 1 minus 1 over 3 minus 6 over 3 squared. Once again, I'm going back to this very first one and plugging in 3. So this is 1 minus 9 over 9, so 1 minus 1. On the bottom, we have 1 minus 1/3 minus 6 over 9 is going to be 2 over 3. So on top you get 0, and on bottom you'll get 0. So y can't equal 3. It can't equal -2 either, but it really can't, like the big one that like was secret was the 3. Hope that makes sense. It's a good question though. So like if you were being very careful with your work, you could say the -2 as well. Oftentimes we don't even, I mean, in this class, the way that we're using it, it won't matter. This part won't matter. But I do like to throw it out there. So we'll be doing a lot of stuff where things cancel and we actually don't care that they cancel. And the fact that it can't equal that won't matter, but we'll get more to it. Okay, so confused how we got -2 since it was positive. So where I'm getting that from, so the denominator cannot equal 0, so y plus 2 cannot equal 0. If you subtract 2 on both sides, you get y cannot equal -2. So it's just setting that denominator equal to 0 and then solving for that equation. No problem, no problem. Other questions? Okay. Trying to gauge how much time I have. Let's do another one of these. So I might walk us through this one. If you look at this and you're like, I think I can do that, then go ahead and just turn your speakers off and kind of work through it, and then you can kind of catch up to us and see if you got the right answer. So if you want to work on this, just mute me and work through it. Otherwise, I'm going to talk about working through this. So the LCD here, if we look at the denominators, so there's this denominator and this denominator, they're the same thing. So our LCD is k minus 6. There's only one denominator to look at, really. And we want to clear out that denominator. So I'm multiplying the numerator and denominator of this big fraction by k minus 6. So distributing, maybe I'll use a little bit of color when I do this. So 1 times k minus 6, you're going to get k minus 6 over k minus 6 minus 1 times k minus 6 on the bottom, you're getting 2 times k minus 6 over k minus 6 minus 2 times k minus 6 These k minus 6's cancel. Really careful that they don't cancel to 0. So k minus 6 over k minus 6 cancel to 1, right? Because anything over itself is 1. These k minus 6's down here will also cancel themselves out. So we have 1 minus, and then the negative here needs to be distributed. So we have minus k plus 6 because we're distributing that negative. On the bottom, we have 2, that's this 2 right here because that's all that's left, minus, and then distributing that negative 2. So minus 2k plus 12. Combining together our like terms, we get, this will be 5 minus k over 10 minus 2k, or wait, not 10, 14. I thought this was going to simplify a little. 14 minus 2k. It can't simplify a ton from here. I thought it was going to be able to simplify a little bit, but no. You can pull out a 2 on the bottom, so you have 7 minus k here. But from there, there's not really much more you could do. So that's supposed to be a... No? Okay. Oh, good. Okay. Yeah. Okay. In the chat, someone's like, can you add numbers? No, I cannot. Just kidding. You're very polite about it. I was like, I know that they made this problem so it was supposed to simplify. So summer brain here telling me this is like 6 minus 1, but no. 1 plus 6 is 7, not 5. Thank you. I was like, I am certain this is supposed to simplify. 7 minus k and then 14 minus 2k. Excellent. Good. So this will simplify just like it should. So then 7 minus k, pull out the 2 on the bottom. 7 minus k. Then the 7 minus k's can cancel. You're left with a 1 on top and a 2 on the bottom. So you get 1/2. Excellent. Excellent. Thank you for that. So much nicer than paper, because normally in the classroom I'm using a document projector and then I'd have to scribble everything out. It's really nice just being able to erase. Technology is amazing. I'm a big fan. Other questions on this one? And for everyone, if you have a question that you don't feel comfortable typing into the chat, you can send it privately to me, and I'll read your question, but I won't put a name on it, so it's completely anonymous. Heck, if you wanted to change your name on Zoom to something that would make you anonymous, as long as it's an appropriate name, I don't care if you use a different name in the chat. But please, if you have questions, ask questions. I don't bite, I promise. I love questions. I think that if one person has a question, 12 people have a question. And especially when it comes to something like you made a math error, please call out my math errors when I make them. Even if it turns out that I didn't make an error, that I did something intentionally that you just misunderstood, your misunderstanding is almost certainly another student's misunderstanding as well. So I'd like to clarify those things. Okay. Okay, there's, see if I can. Find what I'm looking for. Let's go ahead and do one more example. If I could find what I'm looking for, that would be fantastic. So I don't have to make up my own example. There we go. Sorry, I have it. Just give me 1 second. Thought this was in a different section. Okay, that's fine. We'll just do this. So let's talk a little bit about rationalizing numerators or denominators. If you had me for Math 127, then you know that in Math 127, I did not care if you rationalized your denominators. So if you had like 1 over square root 7, I was like totally fine with this. And that doesn't change in calculus. However, there are times in calculus where you may need to either rationalize a numerator or rationalize a denominator. You may need to rationalize either. So in a case where you had, it wouldn't look like this, but in case you had something like this, you may need to switch it around so that the radical was in the denominator. So let's just practice rationalizing numerators or denominators. So let's rationalize the denominator for this one. And we'll do 4 plus the square root of x over the square root of x plus, let's actually do something slightly different than how they did it, 7 plus x, the square root of 7 plus x. All right. Or if you would like, the square root of x plus 7, if it makes you happier to see it that way. Either way is the same. So rationalizing the denominator. To rationalize the denominator, that means that you want to get the square roots out of the denominator. Which is going to mean that you need to, how much time? 2 minutes. It's okay, I can take you guys a little bit over because you can always leave the chat if you can't stay. That means you're going to need to multiply the numerator and denominator by the conjugate of the denominator. So the conjugate of the denominator is just changing the middle sign to its opposite sign. So if this is a plus, you change it to a minus. If this is a minus, you change it to a plus. So the square root of x minus the square root of x plus 7 is the conjugate of that denominator. So I'm multiplying the top and the bottom by the square root of x, not plus, minus the square root of x plus 7. On the bottom, you're going to notice that if you do this multiplication, you have a difference of squares, right? These two terms are the same, except for one has a plus and one has a minus. So if you had something like a plus b times a minus b, the middle terms cancel and you get a squared minus b squared, right? Because you would end up with, the middle terms would be negative ab and positive ab, they cancel. So this won't have any middle terms down here. They'll cancel and you only end up with these guys being multiplied together minus these guys being multiplied together. And when you multiply the same square root by itself, it just cancels out the square root. So for instance, the square root of 2x times the square root of 2x is just 2x. The square root of x plus 5 times the square root of x plus 5 is just x plus 5. On the top, we are going to have to FOIL. So on the top, we do have to FOIL. So looking here, 4 times the square root of x, that's 4 square root x. 4 times negative square root x plus 7, minus 4 square root of x plus 7. Square root of x times the square root of x is x. And then square root x times negative square root of x plus 7 That's negative, and you could write it, you could combine them together because they are being multiplied, or you could write it with two radicals like this. On the bottom, square root x times square root x is x, minus, and remember we don't need to worry about those middle terms, so now it's just square root of x plus 7 times square root of x plus 7 minus x plus 7, and you're subtracting that entire x plus 7 because there is a negative right here. On the top, there's only two terms that can be combined, and I know I'm running over, but I promise we'll be done in just a second. So if you have 4 square root of x minus the square root of x, you can kind of think about this as if you had 4x minus x, and that would give you 3x. This would give you 3 square root x. So we have 3 square root x minus 4 minus the square root of x times the square root of x plus 7. On the bottom, if you distribute that negative, the x's will cancel. You'll have x minus x, and you'll just be left with 7. So the key thing is you're multiplying by the conjugate of whatever you're trying to rationalize. So if you're trying to rationalize the numerator, you would multiply by the conjugate of the numerator. If you're trying to rationalize the denominator, you would multiply by the conjugate of the denominator. And then it's just a bunch of really tedious, yucky looking algebra. So just foiling out a bunch of yucky looking algebra is all. Can I answer questions? So it says, question is, so next week when we start using the unit lecture notes, will you be using Viddle to write out the notes still? Yes. So Viddle allows you to import PDFs. So I forget where it is. It's somewhere on here. They do allow you to import PDFs. So I'll be importing the PDF on here when I figure out how to do it. I've done it before. And then I'll be writing on top of the actual oh, and then someone asked me, how did I get -4? Because I'm just full of typos today is really the answer here. But I will be using those lecture notes and on Viddle. Someone asked me where I got 4. I'll tell you where I got 4, -4. My brain saw -4 and discounted everything attached to it. Yeah, that was not right. There should have been a square root of x plus 7 on here. When your summer brain is still on vacation. Oh, and then there's also a plus. Okay, let's rewrite it. All right, guys. So you combine together these guys, you get 3 square root x minus 4 square root of x plus 7. This plus x is still here. And then minus the square root of x times the square root of x plus 7. Thank you. Somebody called that out for me. I appreciate that. Yeah, that was, my mind's on summer vacation still. So call me out when I do those things. There's some typos, right? Yeah, thank you. Thank you for that. So yeah, so have those lecture notes printed out ready for Monday. Make sure that you've done the things I've asked. I haven't looked through any of the introduction posts yet, although I have seen that a lot of people have done them. I've gone through a few of the scanned documents and made comments on them. Even if you do it wrong, you'll still get a chance to redo it, even if it's past the due date. If you've turned it in before the due date and I didn't like the way that it was turned in, or there's something you needed to fix, I will just make a comment on the document and then you can redo it. So make sure you do the introduction, the replies, change your Canvas picture, and do that practice upload. And then that's the only homework you have to deal with this week. Print off the lecture notes for next week. And when we start on Monday, we will have lecture notes and we will start with actual calculus. And it'll be a lot more structured than this. This was kind of just my willy-nilly algebra review sort of thing. It'll be a lot more structured come talking about calculus. All right, thanks for bearing with me, and I will see you guys on Monday, hopefully. Have a fantastic weekend. If you have questions, feel free to stick around. Otherwise, I will see you guys later. Bye. Let me turn off my recording.